Hello everyone. In this video, we'll be seeing about transmission impairment as well as performance of a network. That is, transmission impairment is nothing but while transmitting the signal, what are the noises or what are the things that affects the signal. And one more thing is performance. That is how to measure the performance of a computer network. So these are the content, that is transmission impairment and performance. So let's see what is transmission impairment. So signals travel through a transmission medium which are not perfect. What happens is signal has to be sent through the wires. Sometimes wire cover will be cut or some noises will adhere to this signals. So the signal will change. That is how the signal is sent. It is not received like that. So what will happen to your data in this case? Data transmitted will not be as the data received. So this imperfection causes signal impairment, and this means that signal at the beginning of the medium is not same as the signal at the end of the medium. That is, what you send is not what you receive. So there are three causes of impairment. One is attenuation, second is distortion, third is noise. Attenuation is some loss of signal. So as it travels over the distance, the signal loses its strength. And next is distortion. That is, distortion happens in case of composite signals. So composite signals are nothing but signals made up of more than one simple signal. So if all the signal will not go together, there will be mismatch in the timing, then distortion occurs. And third one is noise. So some unwanted signal is known as noise. So if that will come and adhere to your actual signal, then there is also a problem in transmission impairment. So let's see the first one, that is attenuation. So attenuation means a loss of energy. So your signal, as it travels over a larger distance, it will lose its energy. For example, if I consider this paper, okay, so this paper, if I throw, how much it will go? Till here. But if I'll wrap something in this, so now I'll throw, so it has gone far away. So what it means? So what is the meaning of that? We'll see in this slide. So when a signal, simple or composite, travel through a medium, it loses some of its energy in the overcoming the resistance of medium. So that is why a wire carrying electric signal gets warm if not hot. That is, when signal is traveling through some wire, it loses its energy due to the resistance of wire, and also because of that your wire also gets heated. Okay, and your electrical energy of the signal is converted into heat. To compensate this loss, so as I showed you a paper, if you throw only paper, it will not go for a longer distance. If you want to make that paper to go longer distance, we have to put something, a chalk or something inside the paper, wrap it and then throw. It will go over a faster, that is, it will go over a longer distance. Same happens in the case of signal also. If signal travels alone, after some certain time it will loses its strength because electrical energy is converted into heat energy. So to compensate this loss, we use something called amplifier, which amplifies the signal, as in the case of paper. So only paper I throw, it will not go for a longer distance. But when I throw it, when I wrap it with something, it amplifies the paper, and paper will travel over the air through a larger distance. So we will see one figure which explains you attenuation and amplification. Attenuation is nothing but loss of signal. That is, signal loses its strength as it travels over longer distance. Whereas amplification is to make that signal to go over longer distance, we have to amplify it. So how we amplify it? We can use the amplifiers. I think in the cable TV you have seen some amplifiers, right? So if you would not have the amplifiers, what would happen? Your cable, sometimes you would have some problem in your cable network. So as seen in this figure, there is a original signal. Okay, so as it is going through the, as it is traveling, it has lost its energy. So your signal amplitude was here, but now amplitude has reduced, as it has lost the energy. Your electric energy has converted into heat energy at point 2. Point 1, this was the situation, whereas as it is traveling through the transmission medium, that is through some wires, at point 2, it has lost its energy to a drastic level. So to gain the original signal, we have to amplify it. For that, we use something called amplifier. So once we amplify, you will get back your normal signal, and still you can travel it over a longer distance. If you will not amplify it, it will go on reducing, and at the receiver you will not get the original signal. So this is about attenuation. And to measure the signal lost or gain, that is strength of the signal, we use a unit called decibel. Okay, so it is also written as dB. It measures the relative strength of two signal or one signal at different point. Next, this factor, that is next transmission impairment factor, is distortion. So distortion, what it means? It means signal changes its form and shape. So assume one signal is given, so it is a sine wave, but as it travels over the medium, it changes its shape. That is nothing but distortion. And distortion usually occur in composite signal, not simple signal. So any idea what is composite signal? In the last video we saw composite signal. So composite signal is the signal which is made up of more than one signal, that is multiple simple signals. If they are joined, then that becomes composite signal. So each signal, so in a composite signal you will have multiple component, and each signal component has its own propagation speed through a medium, and therefore its own delay in arriving at the destination. When a composite signal is going, it will have many components. All the component will not move at the same time. So what will happen? There will be change in shape and form at the receiver. That is known as distortion. There is difference in delay may create a difference in phase if delay is not exactly the same as the period duration. That is, signal components at the receiver will have different phase from what they had received. The shape of the composite signal is therefore not the same. So this is one example. So as you can see, this is a composite signal. Okay, it is having more than one simple signal. It is comprised of multiple simple signal. So this composite signal can be broken down into three components: 1, 2 and 3. These are the components of this composite signal. So this is the actual signal sent, and it has three components at the sender. So at the receiver, what happens? So sometimes if it has, first has reached at the phase 2, that is, there is no phase difference, whereas second one has 90-degree phase difference, and the third one also there is a phase difference. So what was sent is not same as what is received. This signal has changed its form and shape, because there is this signal, that is composite signal, has multiple component, and all the component has not reached properly. This has reached at 0, this has reached with a phase delay, again this is also has reached. So in final signal you have not got the same. So this is known as distortion. And third transmission impairment cause is noise. Noise is nothing but unwanted signal. So unwanted signal, which will be when your actual signal is going outside there, or if two wires are nearby. So one signal will be going this wire, one more signal will be going in one more wire. So what will happen? Maybe some cracks or some leakages will be there in the wires. So what will happen? The signal might overlap, or one unwanted signal can get into actual signal. So unwanted signal is known as noise. So there are different types of noise. That is, one is thermal noise, then induced noise, crosstalk, impulse noise, and these all might corrupt the signal. So we'll see each of these noises in detail. So this thermal noise is random motion of electronics in a wire. So when the signal is traveling in the wire, this some random motion of electronics will be there in the wire, which creates one more signal, extra signal, which is not originally sent by the transmitter. So actual signal will be going because of random motion of electronics. Your one more signal will be created, which will create the problem. Next is induced noise. This comes from sources such as motors and appliances. These devices act as a sending antenna and transmission medium acts as a receiving antenna. Third, type of noise is crosstalk. You have come across cross connection and all, right? So is the effect of one wire on the other. So when wire overlap, sometimes cross connection happens, that one wire acting as sending antenna and other receiving, so there will be a cross connection, both the signal will mix. Next type of noise is impulse noise. It is a spike, that is a signal with high energy in a short time, that comes from power lines, lightning, that is your thunder, because of rain and all. This impulse noise will happen. To measure this noise, we have one this parameter, that is SNR. So how we measure the amplitude using decibel, same way noise can be measured using SNR, that stands for signal to noise ratio. It is ratio of actual signal divided by noise, that is the signal actually you are sending and divided by in denominator the unwanted signal, that is noise comes. So this is one example. So this is the signal you are transmitting, but when it is going in the transmission medium, an unwanted signal is coming. Yes. So because of this, your actual signal is modified. So this is also one of the factor which is changing our data or having some negative impact on our data. So these three were the causes of transmission impairment. That is, one is attenuation, second one is distortion, third is noise. That is, attenuation is loss of signal, distortion is change of the form or shape of the signal, and noise is when your actual signal is coming across with the noise. Now pause the video, draw all the diagrams I have explained, and also write down the points in your books. Hope you have understood about transmission impairment. Now the next topic, that is performance of a network. That is how to measure a performance of a network. You have your two-wheelers or some vehicle also. How you measure your performance? That is based on mileage. So same way we have some parameters to measure your network. So one might be bandwidth, then throughput, then latency and delay. So let's see each of them in detail. So performance is an important issue in network. That is, it tells you how good a network performance is, and it can be measured by the following parameters. That is, one is bandwidth, throughput, latency, and last is jitter. So let's see what is this bandwidth. So how your vehicle has some mileage, same way we have for a network bandwidth. This is used to measure the network performance, and the term depending on what type of signal you have. If you have analog signal, it is measured in hertz. Otherwise, it is measured in bits per second. So if your signal is analog, it is measured in a unit called hertz, otherwise bits per second. So bandwidth in hertz is defined as range of frequency contained in composite signal or range of frequency a channel can pass. So composite signal is nothing but a signal which has many signal into it. For example, we can say bandwidth of a subscriber telephone line is 4 kilohertz, because your telephone uses an analog signal, so it is measured in hertz and we are using one more kilo. Whereas if you are having a digital signal, your bandwidth is measured in bits per second. That is, it refers to number of bits per second that a channel, a link or a network can transmit. So bandwidth is nothing but the ideal performance of your network. How, for example, if you buy a vehicle, maybe they'll tell it will give 60 kilometer per liter of petrol. Whereas actually that is for the ideal condition, but actually when you use the vehicle, the performance will be something else, that is less than that. So same way we have bandwidth. Bandwidth is the ideal performance, that is best performance they are telling, but actually you will get little less than the bandwidth. So that is known as throughput. So throughput is nothing but it measures how fast we can actually send data through a network. So it is the actual measurement of how fast we can send the data. That is, for example, if your bandwidth might be 1 Mbps, that is ideal performance is bandwidth, that is 1 Mbps, but the actual device, that the device connected to the end of the link may handle only 200 kbps. So what will happen, your link might be of bandwidth 1 Mbps, but devices are very slow, they are of only 200 kbps. So when devices are slow, no matter what is there in the between, so two devices are there, middle you have a wire, that wire bandwidth is 1 Mbps, but what is happening to these devices, they have maximum speed of 200 kbps. So it means the throughput is only, maybe bandwidth is 1 Mbps, but throughput, actual this capacity or actual capacity of the network will be only 200 kbps. So one more example we have. Assume we have a highway designed for 1000 cars per minute, but if there is very traffic, that is congestion on the road, then what will happen? 1000 cars per minute cannot travel because of huge traffic. That time only 100 cars per minute can travel. So this actual ideal capacity, best case capacity is 1000 cars per minute. That is known as bandwidth. Whereas actually what is happening, that is known as throughput. In this example, it is only 100 cars per minute. Next comes latency, also known as delay. So latency or delay defines how long it takes for an entire message, because message is going bit by bit. So how long for that message to completely arrive at the destination from the time the first bit is sent out of the source. So latency tell you how much time is required for a complete message to travel from source to destination. So that is nothing but latency, and it is made up of 4 components. One is propagation time, transmission time, queuing time, and processing delay. So formula also is given, that is latency has propagation time. Propagation is time taken for bits to travel from source to destination. Whereas transmission time is time taken for first bit to be sent and last bit to be received at the receiver. That is, when first bit is sent from the sender and the last bit is received at the receiver, that time is known as transmission time. There is one more time called queuing time. That is what will happen. Maybe sender's capacity is 100 kbps, whereas receiver's capacity is only 50 kbps. So sender is sending the data faster, but receiver is slower. So it cannot take that much data. So what it will do, in the middle something called queue will come. Okay. So that queue will be holding the data, so that packet will not will be not dropped. So that is nothing but queuing time, the time these packets are in the queue. And processing delay is time taken to process each of these packets. Then the next performance factor is jitter. We had seen in the first video also. What is jitter? So any idea? Just guess. What is jitter? Yes, it is a problem if different packets of data encounters different delay and the application using the data at the receiver site is time sensitive, then there occurs a jitter. That is, assume there is a big message. So we have one message, okay, M1. So since it is very big, we divide it into packets, say P1, P2, P3. So when you are sending, maybe first packet arrives, P1 arrives at 20 with a delay of 20 milliseconds. Then next packet will arrive after 30 milliseconds, and next packet will arrive after 40 milliseconds. Then we see that there is a jitter. So example, that is, if there is a delay for the first packet is 20 milliseconds, second is for 45 millisecond, and the third is 40 millisecond, then the real time application that uses the packet endures jitter. So this will create a problem where, especially when we have audio and video. So these were the some of the factors impacting on network performance. That is, one is bandwidth, throughput, then delay and jitter. So I think you have understood this. Pause the video for some time and scribble down these points in your books. So now let's see some of the important questions in this topic. So first one is explain transmission impairment. You have to draw the diagram of first write what is transmission impairment, write causes of transmission impairment, and explain each of those, that is attenuation, distortion, and also noise with need diagrams and points. Next question is how to measure performance of a network. So to see how good the network is, we use 4 parameters, that is bandwidth, throughput, and also delay, that is your latency, and fourth one is jitter. So this also you have to explain in detail. So the book I have referred for this section is Data Communication and Networking via Forazon 5th edition. So hope you have understood the topics discussed in this video, that is your transmission impairment and performance. So any doubts you have, you can comment in the comment box, and also take the quiz to understand more about the topic, and the link is given in the description box. So hope you will enjoy watching this. Until then, take care, see you.